Saturn, Lord of the Planetary Rings. Saturn is one of the most fascinating planets in our solar system. It is the sixth planet from the Sun, situated between Jupiter and Uranus. The position of this captivating planet is at about 840 million miles from the Sun, compared to our planet, which is about 9 times less that distance. Saturn is the most prominent due to its astonishing array of rings around it. Locating it at nighttime is very easy, since it shines one of the most brilliant lights in the night sky. Its pale green color enables it to stand out from the rest of the objects in the solar system. It is the second largest planet after Jupiter. Saturn also has the highest number of moons in the solar system, 18 to be exact. Man has attempted to investigate the mystery of this planet by carrying out 3 voyages, with one currently in progress. In September 1979, the Pioneer 2 journeyed to Saturn, followed 1 year later by the Voyager mission, and ultimately leading towards the launch of the Cassini probe in October 1997. Numerous features of this planet make it one of the most astounding in our solar system. Saturn's diameter measures about 72,000 miles, which is about 10 times greater than the size of our planet. Despite its huge size, it weighs much less. It is a planet filled with gas. Hydrogen and helium gases are the main components of the planet, making it less dense. This means that it can float on water. Its light weight, coupled with its fast rotation, make it stretch or oblate against its center. The planet lacks a solid surface due to its gas-filled atmosphere. As a gas giant, spaceships are incapable of landing on this kind of surface. The clouds that are visible when observing this planet form the top component of a very deep layer of liquid hydrogen. Steady winds propel the clouds and attain velocities of approximately 1,000 miles per hour. The systems of rings of Saturn are categorized into 5 main constituents: the G, F, A, B, and C rings. In reality, these main components are divided into thousands of independent ringlets. The visibility of F and G rings is impaired since they are not wide enough, while the presence of extensive thickness enables the remainder to be clearly visible. Speculation has it that the rings are as old as Saturn itself. This has led to the development of 2 major theories to explain the formation of these rings. In the 19th century, Edward Roche proposed that the rings were originally a moon of the planet whose orbit underwent deterioration up to the point that it approached a convenient distance, that the tidal forces were able to shred it. A slight deviation from this school of thought suggests that the moon fell to pieces after having a collision from a huge comet or asteroid. The subsequent theory proposes that the rings never at any time formed part of a moon, but instead were components of bits and pieces that remained during the process of formation of the planet. Saturn reflects the rays of the Sun, and hence increases its brightness, but aided vision increases the visibility of the planet's rings from the Earth. Famed Italian astronomer Galileo Galilei became the first person to observe Saturn's array of rings in the year 1610. He did not identify them as rings because he only observed their edges. He falsely deduced that the system of rings were 2 moons, the same as those he observed around the planet Jupiter. About 4.5 decades later, Christian Huygens, a Dutch astronomer, discovered that what Galileo originally described as moons were, in fact, rings. Huygens had the advantage of using a more advanced telescope than the one used by his predecessor. Even though Saturn's spectacular rings are very wide, spreading from the top of its surface to well past the orbits of the nearest moons, they are thin in diameter, equivalent to approximately 1 mile in width. The voyage by Pioneer 11 discovered several attributes about these rings. They are composed of a variety of particles, from dust-sized particles up to mountain-sized particles. Despite this range, their standard size is about 4 inches. These particles are tremendously cold and composed likely of frozen water and different types of ice. Observations also indicate a widespread cloud of liquid hydrogen that surrounds the rings. The mission of Voyager 1 shed more light on the beauty, intricacy, and the occasional baffling character of the rings. Saturn's rings are composed of thousands of little, thin ringlets with superseding spaces. Hence, the system of rings are noticeable to resemble the furrows on a phonographic record. Even the once perceived vacant space between rings A and B, the Cassini division, measuring 4,800 kilometers in breadth, has many dozens of ringlets. Saturn's dense major rings spread out from 7,000 kilometers to 80,000 kilometers beyond its equator. The major rings have components that range in diameter from less than 1 centimeter to a few meters. The rings have a mass of about 3 quintillion kilograms. This mass is small compared to the massive weight of Saturn. The mission by the Cassini space probe discovered that Saturn's rings have their own independent atmosphere from that of the planet. Molecular oxygen gas forms in the atmosphere. The gas is produced from reaction of ice water in the rings with the ultraviolet rays from the sun. Hydrogen gas is also present. The planet exhibits intricate models of its brightness. Most of the changeability is derived from the varying nature of the rings, and this takes place after 2 phases of each orbit. No matter what the future holds as far as exploration is concerned, one thing is certain: Saturn will continue to enamor the minds of astronomers and ordinary people alike with its truly enchanting rings. Be sure to subscribe for more Space Rewind, and tell us in the comments what you would like to see next in an upcoming video.